Welcome to the online learning platform of MSBTE Learning at your doorstep. I am Sushma Kulle, Head of Electronics and Telecommunication Department from Guru Govind Singh Polytechnic, Nashik. Welcome you all to the presentation on Next Generation Network, in which we will focus on the spectrum in telecom sector. After completion of this presentation, the learner would be able to understand the definition of spectrum, the frequency range of radio spectrum. Concept: the definition of spectrum and electromagnetic spectrum, classification of radio spectrum, and the applications of spectrum. In the concept map, spectrum, we are focusing on the radio spectrum as it is used in telecommunication, and the classification of the radio spectrum and their applications. So let us start with the definition of spectrum. The spectrum refers to the invisible radio frequencies that wireless signals travel over. Electromagnetic spectrum. The electromagnetic spectrum is the range of frequencies, the electromagnetic radiation and their respective wavelengths and the photon energy. The figure shows the electromagnetic spectrum and their applications as per their band. Radio waves, that is, in radio waves, the radio is used, FM radio is the application, cell phone is the application. In microwave, the microwave oven is the application, human body. Under the infrared, the remote controls are used, ultraviolet, visible light, then X-rays, the medical, it is used in medical X-rays, gamma rays that are used in nuclear power. So the electromagnetic spectrum, I think you already studied in physics subjects. The standard bodies and the groups. The following groups and standard bodies have helped to develop the standard so that all the users can be good neighbors with each others who uses the radio bands. So the first one is the ITU-R, International Telecommunication Union, Radio Communication Sector. Second one is the FCC, that is Federal Communications Commission, manages and set the standards with regard to the spectrum use. IEEE, Institute of Electrical and Electronics Engineers, a leading standard organization which publishes the standard that are adopted across industry. Wi-Fi Alliance, an organization that attempts to create a single standard for wireless LAN. ETSI, European Telecommunication Standard Institute. WLANA, Wireless LAN Association. WPC, the Wireless Planning and Coordination, the National Radio Regulatory Authority, and which is responsible for the frequency spectrum management. Now, the next is the spectrum in telecom sector. The radio spectrum is the part of the electromagnetic spectrum and the frequency range is 30 Hz to 300 GHz. The electromagnetic waves in this frequency range are called as the radio waves and widely used in modern technology, particularly in telecommunications. So, from the figure you can see the radio spectrum. The range is 3 kHz to 300 GHz and the applications are start from 30 MHz to 300 GHz. So from the figure we can see that the 30 to 300 MHz frequency, very high frequency that is used in TV white space. The ultra high frequency, that is 300 to 3000 MHz, that is used in medical micro power networks, TV white space, advanced wireless services, commercial space launch. Again the super higher frequency, that is 3 to 30 GHz, that is useful in CBRS, that is the citizen broadband radio services. Again it is useful in unlicensed national information infrastructure. The 30 to 300 GHz extremely high frequency, that is useful in millimeter wave This technology is used in our 5G technology, 5G mobile network, and also it is used in radar. So these are the various radio frequencies and the applications of that radio frequencies. Moving toward the types of radio spectrum. The radio spectrums are classified as licensed and unlicensed. Under the license, there are again three categories: the AM broadcast, FM broadcast, cellular phones. And unlicensed radio spectrum, there are again two groups are given here: ISM, that is the industrial, scientific, medical, and UNII, that is the unlicensed national information infrastructure. So licensed radio bands means what? To use these radio bands, a license must be obtained from the government agency. Means license is required. This requirement is true for all users of this radio spectrum. A few of these licensed radio bands are, as we already discussed, AM broadcast. There are three different ranges: shortwave 1.711 MHz to 30 MHz, medium wave 520 kHz to 1610 kHz, and long wave, that is 148.5 kHz to 283.5 kHz. FM broadcast, the frequency range is 87.5 to 108 MHz. Cellular phone, the frequency range is 840 MHz and 900 MHz. The next is the unlicensed radio bands. So the unlicensed radio bands have been allocated to certain user by the government, or any individual can use it, but to be able to use and broadcast on these bands, you do not require the license. You only need that particular device. Regulations exist around this band. Some of the examples from the unlicensed radio bands are the first one is the ISM, that is the industrial, scientific, medical band. The frequency is 2.54 GHz. This type includes the several medical monitors and other devices that operate in the 900 MHz, 2.4 GHz and 5 GHz bands. Another unlicensed radio bands example is the unlicensed national information infrastructure. This type defines the specifications for the use of wireless devices such as wireless LAN access points and the routers in the 5 GHz band. So this is about the licensed and unlicensed band. Now what is the spectrum sharing? While the mobile network capacity gap keeps widening at an exponential rate. So from the 4G mobile network, the technology is the LTE, that is long-term evolution standard. So it will integrate the number of innovative solutions for the spectral efficiency improvement, and it will prove to be the most advanced cellular technology. So the spectrum has been shared by frequency, space or time domain partitioning, or involving the multiple dimensions in order to improve the overall effective data throughput. The primary focus of the most spectrum sharing mechanism is the interference reduction, and another one is the policy and technology issues. So these are the two more primary focus for the spectrum sharing. Now from the table we can see the three types of potential radio resources for long-term evolution spectrum sharing. So here the TV white space, that is the name. The spectrum bands are mentioned here and shared bandwidth is given, and it is used in TV broadcast. The next one is the CBRS, that is the Citizens Broadband Radio Service. The spectrum bands are 3550 to 3650 MHz, and the share bandwidth is around 100 MHz, and it is used in radar. The UNII, that is the Unlicensed National Information Infrastructure. Again, here are the various spectrum bands and the shared bandwidth start from 100 megahertz to around 255 megahertz, and it is used in the aeronautical radio navigation, then in Earth exploration and space research. So these are the various applications of the spectrum sharing. One more table I want to show you. The spectrum sharing in the 5 gigahertz unlicensed band. So as per the frequency band and the name, the various applications are mentioned here. The frequency range is more than 5 gigahertz and the applications are aeronautical, radio navigation services. Then it may be used in satellite, it may be used in amateur radio science, meteorological aid services. So these are the various applications of the spectrum sharing in 5 gigahertz unlicensed band. Again, some BAN or MBAN are the examples of the unlicensed bands. BAN is the body area network. MBAN is the medical body area network. These are again comes under the unlicensed band. Now, the students can attempt the MCQ set. So, at the end of this presentation, the learners would have got the idea of what is spectrum, radio spectrum, the types of radio spectrum, and the applications of radio spectrum. In the next presentation, we would learn the comparison between the mobile networks according to the different parameters. Thank you and have a smart learning.